Algebra, Chapter 2, Section 9, weighted averages. Just like with our grades, a weighted average is when some values count more than others. And I've given the example here, like our class. Tests are 60%, homework is 20%, quizzes are 20%, a total of 100%, and each has its different weight. That's what a weighted average is. All right, a mixture problem, often found in chemistry. A mixture problem is when you have two or more parts that are combined to make a whole. In other words, you've mixed two things together. You have part plus part equals a total. All right, then we're also in this section going to talk about uniform motion problems, also known as rate problems. And the most popular equation with rate is distance equals rate times time. Anytime you're talking about speed, that's rate, or time that it takes to cover some distance, that's going to be a rate problem. Total distance divided by time gives you the average speed. So let's just jump right into some example problems of each of these. Let's start with a mixture problem. All right, Madison feeds her cat gourmet cat food that costs $1.75 per pound. She combines with it some cheaper food to keep her costs down, and that food is only 50 cents per pound. How many pounds of the cheaper food should Madison buy to go with 5 pounds of the gourmet food if she wants her average price to be, her final outcome to be $1 per pound? So we can think of this as literally buckets. We have a bucket of dog food and of the gourmet. We can even call this gourmet. And we have a bucket of cheaper. We'll call it cheap. And when we add the two buckets together, our new bucket, what she actually feeds her cat, is a combination of the gourmet and the cheap mixed together. So those are our mixtures. So what was the cost of the gourmet? It was $1.75. And the cheaper was only 50 cents. And we want our average in the end, the result to be $1 a piece, $1 per pound. So it says here she has $1.75 for gourmet, 50 cents for the cheaper. How many pounds, here's your question, how many pounds of the cheaper, that's what we do not know, that's going to be our variable. How many pounds, because this is the weight, this is the pounds of gourmet, the pounds of cheaper, and our final pounds. So how many pounds of the cheaper does she need to add to the 5 pounds of gourmet? So she already has 5 pounds of gourmet. Well, someone might say, well, then how much is in the end? How many pounds does she have in the end? I don't know. If I knew how many pounds of cheaper it was going to take, I would add that to 5, and that would give me the total pounds in the end. So this gives us our equation. 1.75 times 5 plus 0.5x equals 1 times, and let's build them a house, 5 plus x times 1. And when you multiply times 1, it doesn't change the problem. So here we go. Multiply times 5, 0.5x equals 5 plus x. And that'll give me 875 plus 0.5x equals 5 plus x. So now I need to find out how many pounds of cheaper I need. I'm solving for x. So let's subtract 0.5 from 1x. Subtract that. That'll cancel. We get 8.75 equals 5 plus 0.5, because we took half away from 1. So subtract 5 from both sides. 0.5x equals, that's going to give us 3.753. divide by 0.5, and x is 7.5. 7.5 what? 7.5 pounds of the cheaper food is what she should buy. Okay? Now, if I was a student hearing this for the first time, I might need to rewind and listen to that one again. So again, I labeled my variable the one that I wanted to know, how many. So let's read this next problem. If you want to pause it and read it on your own and just to check to see if you could set it up, that would be great. You could pause here and read the problem. And now when you come back after pausing, here I go. Cheryl bought 3 ounces of glass beads that cost $1.79 an ounce. She has 3 ounces already. 3 ounces is what she has, and they were $1.79 an ounce. The seed beads cost 99 cents an ounce. So there's some other kind of beads. So this would be the glass. And then there's another kind called seed, and they're 99 cents an ounce. Oh, but I don't know how many ounces. How many ounces of seed beads, I'm going to call that X, does she need to buy if she only wants the beads to be an average of $1.29? She wants, when she puts all of her beads together for her craft project, she wants the average to be $1.29. To be means equals $1.29. I don't know how many ounces of beads I'm going to need. I have 3, and I'm going to have to add to it however much the seed beads, however many of those I need. So I'm adding to it to get a total mixture. So that's how you set this problem up. I'm going to stop. I'm going to ask you to finish that problem on your own, and we'll find out the answer tomorrow. All right, now let's talk about more of a chemistry type problem. John needs 160 milliliters of a 40% sulfuric acid solution. Now, don't get intimidated by the chemistry. It's still math, and we're listening to those numbers, that 160, 40%. He has 25%. He has a 25% solution and a 50% solution that he can mix. So this is what he needs. If this is what he needs, guess what? That's going to be his outcome. The weight of the mixture is 160 milliliters, and he wants that to be 40%, so I'm going to make that into a decimal so that I can do the math. So it's 0.40% of he wants to have a 60 milliliter solution. He has 25% solution and 50% solution that he can mix together. So he's going to mix them together. How many of each must he combine? So he's got 25% sulfuric acid plus 50% sulfuric acid, and we're adding those to end up with 160. Now, somebody might think, well, I don't know how much of the 25% and I don't know how much of the 50%, so let's give them each a variable. And that's good thinking, except we would not be able to solve for a number. Remember when we were doing literal equations with 2 variables, you're going to have a variable in your outcome. Is there a way that I could set this up and actually be able to tell John how much of each he needs? And there is a way. If I know 160 is going to be our final outcome, and I say let's call 25% X, then the other portion must be 160 take away however much X was. Now, if you remember, there was a foreshadowing of this type of thinking in our problems we did in class. We need to think this through. If we want our outcome to be 160 and I have X, then the other amount has to be 160 minus X. So now we're ready to solve this problem. It's nice to put a 0 in front, 0.25x plus, when you multiply 0.5 times 160, you end up with 80 minus 0.5x equals, multiply .40 times 160. I think we get 64. All right, now we're going to combine like terms. These are like terms. 0.25x minus 0.5 is going to leave me with a negative 0.25x. Okay, now my screen didn't keep that. It was a positive 80, so I almost made a mistake right there. So it's plus 80 equals 64. So now I'm ready to subtract 80 from both sides. Okay, so 64 minus 80 gives me a negative 16. Divide by negative 0.25. Negative divided by negative is going to make positive, and x turns out to be a positive 64. So now what did I just find, or what was I even looking for? Let's go back. How many of each must he combine to get the desired result? So how many of each? So I've just found out that 64 was x, and x was 25%. All right, so I need 64 milliliters, because that's our unit of measure, of the 25% solution. And so if I need 64 milliliters of the 25% solution, I'm going to subtract 160 minus 64. I did that on my calculator, and I'll need 96 milliliters of the 50% solution. So that's how you should write that answer. And this video is running long, and I'm going to run out of time. I think I'm going to have to make a part 2 of this section. So I'm going to leave the next 2 problems for you to attempt on your own. I'm going to give you a hint. The outcome here is 0.7 pounds. That's the correct answer to the first one. And the correct answer, or excuse me, that's the correct answer to number 2. And the auto maintenance should be 0.6 gallons. That's the correct answer. So I want you to work and see if you can get these 2 answers for 1 and 2. And we will work those together in class tomorrow. All right, and we'll stay tuned for the second half of section 2.9 coming up. Have a great day.